In this video, we are going to talk about factoring, in particular, a strategy. In other words, we've learned 4 techniques for factoring. So when we're asked to factor, we need to know which technique to use. So let's go ahead and get started. The first thing I want you to think about is if you look at the different types of factoring we do, usually the number of terms determines which technique we're going to use. The only one that's not like that is when we factor out a GCF. So the first thing we're always going to check for is the GCF. See if there's a GCF that we can factor out, and if we have one, we're going to factor it out. Number 2, let's consider if we have 4 terms. Well, we've discussed this. If you have 4 terms, you want to factor by grouping. Another case is if we have 3 terms. If there's 3 terms, we've talked about how to do that. We factor using the AC method. And then finally, if we have 2 terms, there's actually just one technique we talked about, and that was when you have a difference of squares. So again, we're always going to look for a GCF first, because it doesn't matter how many terms you have, you could have a GCF. So once you've done that, you want to look at the number of terms. 4 terms we factor by grouping, 3 terms we use the AC method, 2 terms, the only thing we can do other than factoring out a GCF is if we have a difference of squares, we can factor that. So let's do some problems and we'll remember this strategy as we do. So let's, first of all, a lot of times these questions will say factor completely, or they may just say factor, but notice it's not telling us how to factor. So let's look at these 2 problems first. If you look at the one on number 1 here, we have 3 terms, so you should be thinking AC method. So we need, first of all, our A and our C. A is 1, C is negative 30, so AC is negative 30. Our B term is 7. I should say B is 7, and so we have to find 2 numbers that multiply to negative 30 and add to 7. So first of all, we find our factors. By the way, I do want to point out that in this video we are assuming you know how to use all the techniques. I've already created videos for each type of factoring that we've done. So we'll go a little faster here just because we're assuming you know how to factor. It's just a matter of how to factor, or which technique to use. So here we need 2 numbers that multiply to negative 30 that add to 7. These are all our possible factors. Since these 2 numbers multiply to negative 30, we know we're going to have opposite signs. Because they add up to 7, positive 7, we want to make the smaller numbers negative. So the one that works is negative 3 plus 10. Now before you plug these in, you want to double check and make sure that these numbers multiply to negative 30 and add to positive 7, and they do. So let's go ahead and split our B term, 7x. Notice negative 3x plus 10x does equal 7x, and then it's just a matter of factoring by grouping. We could factor out an x in the first 2 terms, and then for the second terms we could factor out a 10. Notice it should be a positive 10 to make this work, so you want to put a plus in there. So our common factor here is x minus 3, and if you cross out those x minus 3's, you can see the other factor, which is x plus 10. So this factors is x minus 3 times x plus 10. And I would just remind you that if you wanted to check this answer, we could multiply. If you FOIL x minus 3 times x plus 10, it should equal what we started with. Let's move on to number 2. Now certainly on number 2 we have a GCF, and again that's the first thing we should always check. So here we have a GCF. It's going to be 3x, and since there's 2 terms here, we know we'll have 2 terms inside parentheses. We need something times 3x that equals 6x squared. That would be 2x. And something times 3x that equals a minus 21x. That would be minus 7. I want to remind you that we could have found these 2 terms inside the parentheses by dividing each of our terms by our GCF. Notice 6x squared over 3x does simplify to 2x. And the same thing with the minus 7. Alright, let's move on. So let's look at another two problems. Now I hope when you see these two problems, there's a little red light going off in your brain that says, hey, differences of squares, or we have some squares here. Remember, these are numbers that are equal to some number squared, like 1 is 1 squared, 4 is 2 squared, all the way up to 144, which is 12 squared. So we do have in number 3 a difference of squares. So we've learned that we can unfoil these. Basically, we can write this as a product of two binomials, and the first terms should be the same and multiply to 9x squared. So 3x times 3x would be 9x squared, and we need something times itself that equals 25, that would be 5, and then we have opposite signs. So we'll always have the same pattern, that is, we're going to have the same terms here and here with opposite signs in between. And again, if you foiled this out, you would get what we started with. Let's move on to number 4. Now, number 4 is a problem you got to be careful with because it kind of looks a lot like this problem, which is a difference of squares, which we would factor as x minus 3 times x plus 3. But that's not what we have because of that extra x with the 9. So remember what we talked about earlier, we should always look for GCF first, and in fact we have one here. The GCF here is x, and notice that x times x minus 9 does equal x squared minus 9x. And that's all we've got to do on this one. Let's move on to the next problem. So again, be careful, these are two different problems that look quite similar. Number 5 has 4 terms, so we should remember that means we're going to factor by grouping. So let's group the first two terms. There's a common factor of 3x squared, and that would be times x minus 7. So we know we're going to have an x minus 7 when we factor the other two terms. That's one thing we learned about factoring by grouping. And since we have 5x minus 35, we need something times x minus 7 that gives us this. To get that 5x, we're going to need a plus 5. And notice 5 times negative 7 does give you the negative 35. And so we've just got one more step to go. Our common factor is x minus 7. And the leftover factor, that would be 3x squared plus 5. Or those are just the terms we can see when we cross off x minus 7. Now again, I would remind you, you could check this by foiling what you have there, and you should get what you started with. Let's move to number 6. Now it's jumping out at me that we have common factor here, some GCF here. So let's see, 5 is certainly a divisor of 80, and then the smaller power of x would be x, and there's a y to the first power in both. So 5xy is your GCF. Times x squared, that would give us the first term. And then minus 16, that'll give us the second term. So notice what's inside the parentheses here. This is one of the things we got to watch out for. Sometimes we'll factor out a GCF, in fact quite frequently, and what's in the parentheses can be factored further. So you want to be careful not to stop just because you factored out a GCF. Anytime you factor out a GCF, you want to make sure there's no more factoring that you can do. Just look at what's inside the parentheses. So here we do have a difference of squares inside. So we can factor that as x minus 4 times x plus 4. And then don't forget to write your 5xy factor. And so that's our final answer there. We have 3 factors that multiply to give us what we started with. So notice you could even multiply these and you'd get what we have here, and then distribute and you would have what we started with. So again, I would remind you, you can always multiply to check your answers. Number 7. Well, we certainly have three terms here, no GCF, so we're going to use the AC method. So A times C, that's 6 times 12, we're going to get 72, and our B term is negative 17. Now 72 is kind of a big number, and you can go through and find all your factors. What you find a lot of times when you are factoring is that the numbers you see first are quite frequently the ones that work. When I think of 72, I think of my multiplication table and 8 and 9, and 8 and 9 is actually going to work here. The signs should be the same because they multiply to a positive 72, but because these numbers need to add to a negative, they must both be negative. So notice negative 8 and negative 9 are going to work here. So let's go ahead and split our B term. We'll factor the GCF out of the first two terms. It's 4x. So we know we have a 3x minus 2 when we factor the other two terms. And to get that minus 9x, we're going to need a minus 3 there. And that's going to work. We just need to go one more step. And this is our final answer. Let's move on to the last problem. Now in this problem, to start with, you might just see the three terms and think, okay, I need to jump right into the AC method. The only problem is we do have x cubed as our first term. With the AC method, that's always a 2. Or at least it has been for us up to this point. The thing is, we do have a GCF here. It's going to be 4x. Now, anytime your first term is negative and you're factoring out a GCF, we want to factor out a negative. So we'll use negative 4x as our GCF. So let's see, we need something times negative 4x, that's negative 4x cubed. We're going to need an x squared. Be careful with your signs here. To get a 24x squared, we're going to have to multiply by a negative 6x. And then to get a negative 32x, we're going to have to multiply by a positive. It'll be plus 8. So again, we factored out the GCF, but it looks like we've got more work to do because we have a trinomial inside the parentheses, and we know we can use the AC method to try to factor that. Now if we try that and we don't find anything, then we would stop at this point. But this one does factor. So we need a couple of numbers that multiply to 8 and add to negative 6. And it looks like it's going to be negative 2 and negative 4. So let's go ahead and split our B term and factor by grouping. See, we need a minus 4 there. And so our final answer is negative, or when we factor this, we get x minus 2 times x minus 4. And actually, we're not quite done here. I need to fix this. Let's see. We did not, I forgot to put the negative out front because our final answer should have the negative 4x in it. So final answer is negative 4x times x minus 2 times x minus 4. And that will finish us off. And so that is the end, and good luck when you guys start doing this on your own.